Okay, guys, can you see my screen?
Yes,
Yes.
yes.
Yes, yes, we
Okay,
can see it.
okay, that's great. So we were studying about indexing and slicing, and it was indexing and slicing is mainly how to access elements or sequence of elements from data containers. But obviously, we did not study Python's dictionary. So dictionaries they don't have any order. So dictionaries key value pairs that goes into dictionary, they are unordered. So the question is how to access elements, access values associated with different keys from dictionary. So numerical based index does not work because numerical based index needs sequential data, ordered data. So yeah, so like I will spend some time on accessing elements from a dictionary, and then we will proceed to the mutability of data structures, a very important topic. It's very important to have a good understanding regarding the mutability of data structures early on. So, okay, so let me ask you how many key value pairs we have here quickly. We have four key value pairs. So this is a key for first value and its value is one. So you each key value pair is separated from the next key value pair by a comma. And you can here see that uh, how we have created dictionaries. We create dictionaries with curly braces, and we also create sets with curly braces. Yeah, but obviously we can differentiate between the two because we sets have don't have key values. All they have is the unique, unordered uh, elements. So yeah, so let me delete this. Okay, so let's suppose that if we want to access a value associated with key with this key B, so how we will access it? So what we will do, this is the name of the dictionary. Okay, this is the name of a dictionary. So it's a variable, and variables are nothing but they hold reference to the object in a memory. So this variable name my underscore dict holds a reference for this dictionary at some memory location, and you can access it value associated with key B. First, you what you have to do is to give the name of the dictionary, then again square bracket and the name of the key. So key. So this will you will able to get two. Okay. So let me run this code. Uh, you let me run this code quickly. Yeah, you can see that you can access values, and if you want to access all the values, for loop is always there. Dictionaries like tuple, uh, dictionaries like tuple list are iterable, so you can always use for loop over them. We have not studied for loop, so it's okay. We will study iterations tomorrow, and you can access all the values associated with the keys here. So yeah, by using for loop. So we also have methods. So let's suppose that if I want to get all the keys, so this is a method. So dot keys is a method that works only for dictionaries. So and it returns, and I don't remember what is the data structure it returns, but you can cast it to string by putting it inside the string. So yeah, so this is, so it will give all the keys in this dictionary. Okay, this method will give all the values in this dictionary, and we also have items method that can retrieve both key values. So if I yeah, but obviously there is no point in accessing all keys or all values. Sometimes you need maybe few keys, a few values associated with with some keys. So you need to have you need to access few values. So how to do it? So what you will do, you will again write a list comprehension. So list comprehension, let's suppose that you want to access, I'm here, let's suppose that you want to access values associated with key A and key C. So simultaneously, that's what you want to do simultaneously. So what you will do, you will create a, a, a list of keys. So this is a list of keys. So yeah, it's a list of keys, and then you will use that list in list comprehension. So what you are doing here, so list comprehension, so you can understood this list comprehension as for each key in this list of keys, what I will do, I will try to use this expression. So this expression is basically for what is the so if I run this part, so what will be the value of key? What will be the value of key for the first iteration? What will be the value of key for the first iteration? Quickly. What will,
One. One.
no, A. A. So for key in keys, so this will be, so iteration means, so this key will take the value A in the first iteration. They, in the second iteration, it will take the value C in the second iteration. Okay. So you can see in the first iteration, so this expression, uh, so when this expression for the first iteration will become my underscore dict. Uh, so this will become for the first iteration something like this. Okay. And what will be, what will this give you? What value will this give you? This will give you 1.
One.
And for the second iteration, when the value of key will be is equal to C, this here we are going to have C. This expression will be, this expression will be this. So what is the value associated with C? 3. So it will give you both values in a list comprehension. So if you want to access some values associated with keys in a dictionary, you, what you need to do, you need to write a list comprehension. So the first step is to create a list of keys for which you want to access values. So we want to access values for keys A and C. So you will create a list, and then you will use that list. Then you will iterate over that list using list comprehension and return. This will be the expression that will be returned. So here we are simply accessing the values. So this is the syntax for accessing the values. So yeah, this is how we access values. Yeah. Any questions? Don't hesitate to ask questions. I mean, questions are very, very important. If there is anything you don't understand, that's important. So let me ask you a question. So how many key value pairs we have in this dictionary?
Imran, can I ask some question?
Yeah, go ahead. Go ahead.
Uh, I think that the key and keys, what is the difference between key and keys?
Okay.
Uh,
Yeah, that's a good question. So basically, this is the syntax of for loop. So for loop, so this key, basically, you can give it any name. So it does not have to be a key here. Okay. So you can like, let me change. And but this keys is the name given to the,
variable names.
yeah. So this is a name given to this list. But this key could, you could give any name. Like I could change it. Let me change it. Maybe if it is confusing you. Yeah. But obviously we have not studied yet for loop, so it's okay if it is confusing you now. So let me give for I. Here I will change I. So yeah, it returns to, or you can change it J. Here expression you will also change J. So yeah, or maybe you give Imran. Here you can give Imran.
Imran.
Yeah. So I mean, this has to be any name. So it's not an issue. But here, for just for the sake of more clarity, I named it key. Okay. So it could be any short variable name. It could be any short number variable name. So yeah. So yeah, that's that.
Function.
Yeah. Question. Go ahead.
It it is function that is defined my dict.
So it's not a function. So it's sort of a variable name which you have to create on the fly. But yeah, but you can give any name. You it does not have to be a key. It does not have to be a key. So yeah. So all this part of the code does this part of the code does is to loop over each element in this iterable, which the name of that iterable is keys. And this part tells you what operation you want to do on each element. When you will access each element of the list, what you will do, you will simply access it, and you can do a lot of things with it. This is an expression, so it will return a value. This is an expression. Must be an expression. It must returns a value. Okay, and this is how you are iterating over some list or tuple or any iterable. So it lets you iterate over anything. So yeah, I mean, it will be more clear to you in tomorrow's lecture when we will study iterations, when we will study for loop. But here I'm just including list comprehensions for maybe just to explain you how to index and slice. So the purpose is to explain you indexing and slicing, but we will come back to this concept for loops. I do understand that it is difficult to understand list comprehension without explaining you in detail for loops. So yeah. But obviously, indexing and slicing is discussed before discussing the for loop or iterations. Yeah. Okay. Any other question? Okay, so how many list how many key value pairs we have in this list? So
Mainly
what is it?
two keys, mainly two keys, but nested four keys.
Yeah, two keys. So outer key one and outer key two, these are the two keys. And we have two key value pairs. But as we have discussed, that the dictionaries are very flexible. So we have some limitations on the keys. That key must be unique and key must be of immutable data type. But there is no limitation on the values of dictionary. The values of dictionary could even be dictionary itself. So this is a nested dictionary. So this is a dictionary, and this is another dictionary as a value. So yeah, and you can even give a list as a value or tuple as a value. So there is no limitation on the values of dictionary, though there is a limitation on the keys of dictionary. So the keys must be of immutable type and they must be unique. So that's something very important. So okay, we have so we have nested dictionaries in a dictionary. So the question is how to access a value associated with this key, inner key. So how to access? So first of all, what we will do, uh, what do you think what do you think if I run the code, this part of the code only, what will I get in the circle? What will I get quickly?
Two.
You will get the whole dictionary. This will give you the whole dictionary. This will give you the whole dictionary, this key. So if you run this code, if you run this code, So it will, what is the value associated with outer key? So this dictionary is associated with the outer key. So it will give you this um, uh, so this code will give you the value associated with outer key. But if you want to access a value which is nested in a which is nested in another, which is nested in dictionary, in this dictionary. So you want to access this value associated with value one associated with this key, okay, with this key. So you need to create another bracket and the keys, okay, another bracket and key. So this is how you will get one, okay, this is how, okay. And yeah, so yeah, is this clear to you? I mean, is this clear to, so how you will access, how, what changes do you need to make, what changes do you need to make in this code to access this value? What should be here? What should be here?
Outer key 2,
Outer key 2. That's great. And
uh,
then
inner key 4.
inner key 4. Excellent. So this is what you need to do to access. So you can access even elements which you can access the key value pairs values in a nested dictionary. So you can access values which are nested in a dictionary. So yeah, so this dictionary is a dictionary that is nested in this outer dictionary, okay, this outer dictionary. So and you can access the values associated with the keys here. So yeah, that's great. What do you think, what I will get this, what will be the data structure I will get this if I run this?
Inner
Quickly.
key 3 and the
Data
inner
structure.
key 2, 4.
Yeah, data structure. What is the data structure? It will return us a key. It will return us a dictionary. So this will give us a dictionary. Okay, this will give you a dictionary. So that's very important. So yeah, this will give you a dictionary. Any questions so far?
No.
Okay, that's great. That's great. Okay, I mean, I totally understand it needs some practice, but if you spend some time, it won't be difficult for you to understand. And just to give you more practice about list comprehension, using list comprehension for slicing. Yeah, so let's suppose that this is a list comprehension. You see this, this is a list. This is list. How many elements we have in this list?
12
12.
elements.
12 elements. So so I mean, you can understand that if it is a bigger list, and if I ask you to give me all the odd numbers, all the even numbers, all the numbers greater than some number, so it is very laborious to create a list of the position. Like, so if I ask you to create to give me all the even numbers, so one approach is to like find the position of all even numbers manually, create a list, and then loop over it. So here, let's suppose that, okay, this is an even number, 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 this is the even number, this is a even number. So this position is 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe you can also create a list. You can create a list for these indices, and then you can use list comprehension. It is possible, but obviously it's very laborious, and yeah, but you can create a Boolean condition. You can create list comprehensions are very powerful. You can even add conditional statements in it. So what's the way to add conditional statements? So you can filter out all the elements which are not divisible by 2. Yeah. So this is a code. So this here we are iterating. This is our iteration. This part is iteration. This part is we are adding a conditional. So this will ensure that if a number is not completely divisible, it will be thrown out of the list and this will be returned. So yeah, this is an expression. This is a loop iteration expression, iteration, and this is a conditional. So if so what will be the value of so this j here we are using a variable named j. So the j is iterating over all the elements in my list. So it is checking whether -5 is completely divisible by 2 or not. So it returns false. In case of -5, it returns false. So this number will not be part of the list comprehension. So then it goes second number. So the j will be 8. So this condition is true. So this condition is true. This part of the code condition is true. So j, so here j will be the 8 will be included. So first element will be 8 will be included. So yeah, if you want to add conditional which filters out the unwanted element from a list, from your output list, so you need to add a conditional after for loop after this sort of a statement. So yeah. Okay, so I mean, it may be a little bit confusing for you in list comprehension, but list comprehensions are very powerful. And once you develop the hang of it, it's easy. So if there are no conditional, then list comprehension is very simple. Like it has expression and it has iteration. But if there is a conditional, a filtering conditional, and conditional could be also of different type, a filtering conditional, filter function. A filter function is some sort of a where you want to filter out, where you want to remove unwanted elements. So you don't want -5, you don't want 1, you don't want 3. If you are looking for odd numbers, even numbers, you don't want 67, you don't want 69. So this will so for odd number, this will be false, and for even number, this will be true. And so that number will be included, will be part of the, will be shown in the output for which this conditional is true. So yeah. So yeah. So can anyone explain me? Can anyone? I mean, don't worry about right or wrong. Just try to explain me what I am doing in this. Let me show you. So what I'm doing here. Anyone? Make an attempt.
I think you want to print numbers that are positive.
Yeah, excellent. So I only want numbers which are positive. So I don't know about their positions. I don't need to know their positions. All I need to do is to add this conditional, and it will filter out, it will remove all the negative numbers. So so for k, so for the first element, what will be this? What will this conditional give? True or false?
False.
False. It will give false. It will give false. So this k here will not be the part of the output. So -5 will not be the part of the output. So then we are looping over the second element, which is 8. And what about this conditional for 8?
Yeah, it will give true in this
True.
case.
And then k True. And then this will become the part of the list. So this square bracket in a list comprehension ensures that we have a list comprehension. So yeah, I mean, this is very, very powerful. So if you want to access elements which meet some sort of a Boolean criteria, you can use list comprehension, and you don't need to know the position of the elements. You don't need
I have a I have a question, please.
Go ahead.
Yes, in the previous line codes, I don't still understand why you have 0 and 1, where you have double equal sign 0, double equal sign 1. I don't understand why you have 0 and 1.
Okay, that's a great question. So yeah, so this is basically, this percentage sign is modulo operator. This is modulo operator. And what this gives. So let's suppose that I is so this is modulo. So this means when you divide I by I percentage 2, what is a remainder? Okay, what is a remainder? Okay, so so you have a 5. So what is the remainder here?
The remainder is 1.
1. So 1, then you are comparing 1 double equals to 1. So is it true or false? 1,
It's
this, yeah, go ahead.
Yeah, it's true.
True. So basically, this is a condition to check whether a number is odd number. This is a condition to check whether this is an even number. So yeah,
Yeah, that's clear. But I want to ask why we didn't use one equality sign instead. I know there is a reason, so I want to know the reason. Sorry.
So can you repeat your question? Sorry, I mean your voice is breaking.
Okay, I was saying I know there is a reason for using double equality sign instead of one equality sign. So what is the reason
Okay, so that's a very
why we didn't use one equality sign?
okay. So one equality sign is an assignment statement. Double equality sign is a equality statement. So if you want to check the equality of the values of two objects, you use double equal signs. So here, if you can see here, we have a single equal sign. So this means that this variable name is pointing to some object in a memory. So this is a assignment operator. So it is just create. So let's suppose that, okay, this A,
Okay,
let me delete everything. Let me delete everything first. Okay, so no, it's a good question. It's an excellent question. I mean, students have a lot of problem. Okay, so 1000. So this, when you have like statement like this, A equals to 1000. So this is an assignment statement. So this means that a variable A holds a reference to an object at some memory location. So this is basically, this box is, you can think of a memory location. You can think of a memory location, and this variable name, when you run this assignment statement, you create a reference a label or something that points to this object. Okay, so it does not check the equality of the equality of the of object. So double equals to is to check the equality, and it is a what it is called Boolean operator. So it's a Boolean operator, like comparison operator. So it is a comparison operator, and it is also a comparison operator. So it gives you true, false. Okay, but single equals to is not a comparison operator. It's an assignment operator, and yeah, and
okay, thank you so much.
yeah, you use it all the time. You use it all the time. Okay, yeah, that's great. Any other question? Don't
No
hesitate.
question.
Yeah, that's great. So I mean, here is another. Let's suppose that how many elements we have in this list?
Five
We have
elements.
5 elements.
5 elements. So if I ask you, I mean, the names with 4 or more characters. I want to convert these. I want to change them to uppercase. Okay, so you can again do some sort of a list comprehension. So what you can do, so here, this will give you all the names. This statement will be true for all the names having 4 or more than 4 characters. So this name has 4 characters. It will not be a part of it. This has 5, more than 4. It will be a part of it. 1, 2, 3, 4, 5. This will be a part of output. This will be a part of output. So I want to convert into an uppercase. So each character should be uppercase. So this is what you will do. Okay. So I mean, list comprehensions are very, very powerful, and yeah, you can use them in variety of situations, and you can also use here in you can also use here for indexing and slicing. I mean, it's a very, very powerful technique. So I have already included a blog from real Python. I mean, if you read that blog, that will be great. List comprehension. But obviously, I will explain you tomorrow iterations, and iterations include more like a traditional for loop. So list comprehensions are nothing but just a traditional for loop, but it's in the more concise way. It's in the more concise way. So yeah. So this, we are here now. We have to. Can you see my? Okay, cancel. Can you see the other? Let me stop share for a second and let me share. Okay. Okay. Can you guys? Okay, why is this? Both are there. Okay, let me. What do you see now? Do you see anything?
We are seeing yours. Okay, it is not showing now.
Okay, give me a second. I mean, I think I need a second because I am going to start a new topic. Okay. Okay, I will share the link. I mean, links is already there in my reading list. So, but yeah, it's already there in the reading list. But I will because when I will send the code for today's lecture, I will share the links. Okay. So yeah. Okay. Now, this lecture focuses on the question of mutability. Some students asked very good questions on mutability, and I did not answer them. Today, I'm going to answer their questions. So I just asked them to postpone seeking answer for mutability, and now is a time. Now is a good time to explore the topic of mutability. Mutability. It's a very important topic, and before we study mutability, we I just want to give you some refresher about this is operator and doubles equals to sign. So can anyone differentiate what is this? What's the difference between is operator and doubles equals to operator? There is no deduction of
Yes,
credit. Yeah, for wrong.
double equality. Okay, and I think as we learned, double equality means it means two or more objects they have the same values. While is it considered them they must have the same value in the same memory.
So yeah,
Can I also give my own point?
okay, go ahead.
Yes.
Yeah, I think double equality sign means it's a kind of a logical operator, and then the single equal sign is an assignment operator.
Yeah, but what's the difference between this is operator and doubles equals to sign?
Hello, can I give my own contribution?
Yeah, go ahead, go ahead.
Okay. Double equality sign assign the value from left to the right, while equality sign is just an assignment operator.
Yeah, I mean, yeah. So let me explain you the
The
difference between.
difference that for example, identity operator is, it means if two or more objects they have the same value in the same memory, then it will return true. Otherwise, it will return false.
Yeah. So
Then equality operator, it only check if they have the same values,
yeah,
irrespective the memory.
yeah.
It will
So
return true.
yeah. Yeah, so the is operator is basically it tells you whether the two objects share the same memory or not. So that's a question they are going to answer. So whether the two. So let me here this is a box showing the memory address. Okay, so like if I put like 999, so here A. So this is B. So what do you think that what will be the result of A is B? True or false?
True.
True, because A and B are referring to the same object in the memory. And even A double equal
Yes.
to B will also be true because both variables have the equal value. So it's equal. Okay. So yeah, this is very important. This is very important. Let me ask you another question. If again, let me delete this. So maybe if I okay this 57. So you can think of this box as a memory box. Okay, you have another 57. So this is A is pointing to this memory box and B is pointing to this memory box. So what is A is B? What is A?
False.
Which one is false and which one is true? Or both are
A
true?
is B is false because A it has different memories as B,
Okay, that's
while A equals to B is true because they have the same value.
yeah. So this equality sign checks whether the two objects, it checks the values associated with two objects, irrespective of their memory location, whether they are located in the same memory location or different one. It just checks the values. While this A is B checks the whether the two objects exist in the at the same memory location or not. So that is what it is. Yeah, very important. I mean, today's lecture will be based on these two concepts. So you have to be clear about it. And ID function give you the memory location. So if I say ID of A here will give me the memory location of this object. ID of B will give me the memory location of this object. So this object, okay. And ID of, what do you think? ID of A will be equal to ID of B or they will be distinct? Each box has its unique memory address.
So you
So
come again.
Distinct.
each, say, please say it again.
They will be distinct according to me.
Yeah, excellent. So ID of A will be different or distinct from the ID of B. So yeah, so these things should be clear to you before we start our journey related to mutability. So that these things will be the building blocks, and we will use these building blocks to understand, to break down complicated topic of mutability. Okay, so yeah, very important. Yeah. Any questions? Any questions? No questions. Okay, that's great. Okay, so first of all, I made this statements. I made this statement multiple times that int. So what do you guys think about int, float, float, uh, string, Boolean? So I made a statement about these basic data types multiple times, that they are of immutable type. So these basic data types, all of them are immutable data types. Okay, I did not explain you what does this mean, immutability. So today I'm going to explain you what does we mean about the immutable data types. And we also have, okay, what about lists? Lists are mutable or immutable? List mutable or immutable?
Mutable.
Mutable. So you can append a list, you can add a new element, you can remove a new element, you can modify an existing element. Lists are mutable. What about tuples?
Immutable.
Tuples are
They are
immutable.
not.
Yeah. What about dictionaries?
They are
Mutable.
immutable.
Mutable.
Mutable.
Yeah, dictionaries are mutable. The values associated are mutable. Keys are immutable. So dictionaries, yeah. So you can add a key value pair. You can update a value associated with the existing key. You can remove a key value pair. So dictionaries are mutable. So we will understand what does this mean actually. So first of all, immutability of the basic data types. What does that mean? Let me give you a definition first. So once you have created an object of basic data type like int or float or a string or boolean, and after creation, if you try to modify the basic data type, you will not able to modify that data type. What you will actually do, what will actually happen, you will create a new object with a different value at a different memory location. So okay, let me delete this. Okay. So let's suppose that this we have this is 50. So you ran this assignment statement A equals to 50 on some Jupyter cell, and this is what is happening behind the scene. Okay, this is what happening. So let's suppose that you try to modify it, and you, instead of 50, you want to give it a different value. You want to maybe say now A is 75. So what do you think? The A will be modified here, or A will be, another box will be created. Another box will be created. We will create a new object with 75, and the reference, the previous reference will be deleted. So there will be no reference to this 50. Okay, so there will be no reference. So again, this is an integer. This is of immutable data type. Once you have created an immutable data type and you try to modify that data type at the same memory location, you will not able to do it. It's not possible. So what you will do, you will create this assignment, you will create this modification at some new memory location, Okay. So so that is why we call it immutable data type. So once you have created immutable data type, yeah, it's not possible to modify after creation. All you will do is to, all you will end up having is to have a new object at a different memory location. Okay, so yeah, so let me maybe show you some code here. Okay, okay, okay. First of all, here, this is a, what is the data type of this 2500?
Integer.
Integer. And it exists at this memory location before we have modified it. So it exists at a different memory location. Now we want to add one to it. So let's suppose that we add one to it. So we are trying to modify A. We are trying to modify A. So we will not able to modify A at this memory location. What we will do, we will end up creating A, modified A at a different memory location. So the memory location of these two are like before modification and after modification will be different. So you can see that. Yeah. Okay. Yeah. Can anyone explain me what I'm trying to say again? Trying to say here. So maybe give it a try. So I will know whether I'm explaining it right, whether you are not understanding it or not. So I will make an attempt again. It's okay. I mean, there is no credit for wrong answers. I mean, I totally understand this is a difficult topic, and initially it's difficult to wrap your head around this topic, but it's okay. Yeah, make an attempt. Making an attempt is more important than giving a right answer. Let me tell you in programming. Yeah, go ahead. Okay, let me explain your game. So let me explain this example. So okay. So what? So first of all, you can think of this as you have 2500. Okay. So this 25 exists at this memory location. So I'm only writing the last three digits. 640 is a memory location of this. 640 is a memory location of this box. Now I have created this immutable data type and I want to modify this immutable data type. I will not able to modify this immutable data type at the same memory location. Even if I try to do, what I will end up having, I will able to create a at a different memory location. So now I want to add one to this. So if when I try to do it, I won't able to do it here. So this is not possible. So I won't able to do it here. So it happens at a different memory location. Okay. So it happens. We have a modified 2501 bound to variable A at a different memory location, and this reference will be removed. Okay. So because this was of immutable data type, you cannot modify that data type in place. Okay. Once you have created an immutable data type, it is not possible to modify it. All you will end up having is to create a new object at a different memory location. And this new object has 592 memory location. The last three digits I'm just like, so yeah, so this is a new memory location. Similarly, string is of immutable data type. Okay, so you have to see if the ID of some data type or data structure is different before and after modification, then it is of immutable data type. So here I'm adding strang. So I'm modifying this Gilbert, and I'm trying to add strang. So ID varies. So I am not able to modify this Gilbert at the memory address. So what I will able to do, I will create a new object in a memory, new object in a memory. So that's very, very important. So that's why we call int, float, int, uh, int float, str are immutable type, str string are immutable type. Anyone want to make an attempt? Please go ahead and make an attempt. Why these four basic data types are immutable? Just make an attempt. What does this mean?
Let me try. It
Yeah.
means you can change them only if you change their memory location.
Excellent. Very simple, very accurate, even better explanation. That's excellent. Better explanation than me. So maybe repeat it one or two times so that your colleagues could also understand. Yeah. Can you say this again? Can you please say this again? One more time?
Yeah, I was saying that for this data type, you can only change them if you change the location memory,
Yeah,
the
excellent.
memory location.
So yeah, now I mean, if anyone else wants to like say the same thing in their own words, it will be great. Yeah, it will be great. So that's why there are immutable data types. Okay. Now again, so let's suppose that you have a list. We have said that lists are mutable. So I want to, okay, um, this is a list. Why list is immutable? So let's suppose that ls is a list and ls resides here. So this is a list. 5, 9, 10. Okay. So I want to add an element. I want to append an element in this list. Okay. So what I want to do, I want to run this type of code like ls dot append. I'm adding like -99, okay, to the end of this list. So I will be able to do it. I will able to do it because the list is, I will able to do this mutation at the same memory location because list is mutable. List is mutable. So this -99 will be added. So we are going to have a yeah, we because lists are mutable, so it is possible to mutate the list at the same memory location. So a new list won't be created. A new list won't be created as we were creating in the case of immutable data type. Okay, so immutable data type. Once immutable data type is created, there is no way of modifying it. If you want to modify it, you will end up having a modified value at a different memory location. You won't able to modify the immutable data type after creation. But if the data type is mutable, it is possible to modify in place. So you are modifying the original list at the same memory location. That's why it is called um, um, uh, mutable. Okay, let me give you an example here. So okay, let me clear. Okay, it's okay if you find it difficult, but that does not mean that you should not try to understand it. Okay, so that's very important. Okay, so you have this list and you want to modify this list. You want to add 4. Okay, you want to add 4 in this list. So what do you think? What will be the ID of these before and after modification, will they be same or different?
Same.
Same. Excellent. Excellent. Because IDs will be same, because the reason is list is mutable. List is mutable. So if you try to modify it, you can modify it at the same memory location. So that's what it means by mutability versus immutability. Okay. So yeah, and tuples are immutable. Tuples are immutable. So what do you think? What will happen if we try to modify it? What will happen? So IDs will change. IDs will change. So there is no way to modify immutable data type. All we will do, we will end up creating a new object in a memory. So this T has one memory location, and this T after modification has another memory location. So this T is not referring to this T does not exist, does not share the same memory as this T. Okay. So because tuples are of immutable data type, that's very important. If you try to modify an immutable data structure like tuple, all you will end up having is a new tuple at a different memory location. So IDs will be different. IDs will be different here. IDs are the same in the case of list, because list is mutable. You can modify the list in place. Yeah, it's possible. Int, float, string, boolean, they are of immutable data type. So there is no way of modifying them after creation. Once you have created them, if you try to modify it, you will create a new object with a different value at a different memory location. That's what will happen. So yeah, but obviously we have to go deep now. We have to go deep, and this is important. I mean, deep copy versus shallow copy concept we have to cover. Okay, let me delete this. Any questions so far? I mean, I am expecting you guys to ask a lot of questions. Even you don't understand, it's okay. I mean, yeah. Yeah. So anyone can anyone like summarize the difference between double equals to and is operator again quickly? What's the difference between these two? What's the difference between double equals to and is operator? Quickly. Anyone wants to make a try? Probably this is the most difficult part of Python. I mean, I do understand, but yeah. Okay. So again, double equals to checks whether the values of the two objects are the same. Values of the two objects are the same, irrespective of their memory location. Is operator means it checks whether the two objects share the same memory or not. So that's a difference. And you more often you will see double equals to sign. Okay, double equals to sign. It's very important to know the difference between them. And the lecture is based on these three things. Double equal to, is, and ID. These are the three things. These are our Lego blocks for understanding this concept of mutability. And yeah, so yeah, it should be in your mind all the time. Yeah. Okay. So let's discuss a simple example. It's a simple example. Um, uh, so first of all, not only these data containers have IDs, but their elements have their own IDs. Their elements have their own IDs. Okay. So that was so the data containers are complex in this case. So the ID of the whole data container and the IDs of its elements are different. Okay. And you can see that You can see that here. Let me. Okay. So what do you guys think about this? So what is the data structure of T1 and T2? And how many elements T1 and T2 have?
Each of them is a tuple,
Excellent.
and each of them has 3 elements, and each of them has embedded nested list.
Okay, which one of them is mutable and immutable?
Actually, both of them are immutable because they are tuples.
Elements. I'm talking about elements. So, like we have 3 elements. So, which?
Well, if we convert a tuple to the list, so the list itself will be mutable, but each element of them will be immutable. But this embedded, the nested list will be mutable.
Yeah, so that's very important. So now, okay, so we have 3 elements. So 3 elements means we have this like, so this is integer, this is immutable, this is integer, this is immutable, and this is a list, which is mutable. So what happens? So now let's ask a question. What happens if you have a mutable data structure in an immutable data structure? List is a mutable data structure and tuple is a immutable data structure. So can you modify uh, list? So that's a question. Okay, but obviously, go ahead.
If we want to modify a nested list, we have to convert the tuple to a list at first, and then we can access the third element and modify it.
Okay, but the thing is, we can modify a list inside a tuple. So we can modify a list inside a tuple. We can modify a mutable data structure inside a if it is inside the immutable data structure. And yes, this is possible. We don't need to convert it into a list, but obviously it's not recommended to have a mutable data structure in a immutable data structure. But if you have for some reason, then we can modify it. Okay, so let's postpone this question again for a minute, and let me ask you some basic questions again. So I mean, just to slowly build. Okay, so let me. What do you guys think about these? This. Okay, where is my pen? Okay, so what do you guys think about T1 and T2? So T1 double equals to T2. What do you guys think about this statement? This is T1 double equals to
Yes.
T2.
Yes.
That is yes. And what about T1 is T2?
No.
No. Okay. Would you like to explain your answer to your colleagues?
Because T1 and T2, they don't have the same how to say that ID, I think.
Yeah, yeah. Excellent. So you can see that T1 and T2 have the same context, same values. So obviously this will be equal. So you will get true. But way you have created them, it is clear that T1 and T2 are the two distinct objects in the memory, and even their elements are distinct. They don't even share the elements. So you can see the with the IDs. So can you tell me what I'm doing here? What I'm doing here? Anyone?
I think you are trying to get the location of the first element of T1.
Excellent. So here I'm trying to you find the memory location of the first element. Here I'm trying to find the memory location of the second element in T1. Here I'm trying to find the memory location of the third element in T1. So with indexing, you know that this is a syntax for this is T1, name of the tuple, square bracket, and this is what we are trying to, and I'm printing it. You can see that each element has its own memory index, memory address, sorry. Each element of the tuple, each element of the data container has its own memory address. And we also have a memory address for this T1 and T2, and also has a memory address for its elements. And you can see that um, this is a memory address for this 1000, and this is a memory address for this 1000. They are different. Okay. Yeah. So this is a memory address. Let me use a different color. This is a memory address for this, and this is a memory address for this. Okay. And yeah, so here so this T1 and T2 have their own identities, and their elements have their own identities. So they exist, they have their own boxes in memory. So that's something very, very important. And what do you guys think? Obviously, as I have already answered that it is possible to mutate. It is possible to mutate. It is possible to change or modify a mutable data structure and an immutable data structure. So list is a mutable data structure, but it is inside a tuple, because it is inside a tuple which is of immutable type, and it is possible to mutate a list. And now let me delete this. Let me delete this. Okay, let me delete this. Okay. So we know here, like T1 double equals to T2 will be true, but obviously IDs T1 and T2 have their own independent IDs, so it will be false, and it is also false. These two lists, they have their own memory address. So they have their own memory address. Okay. So if I append an element, so what I'm doing here, can anyone tell me what I'm doing here? Here.
At 99, after
Yeah, go ahead.
at 99 after -1 in tuple 1.
Yeah, so this -1 is a list. Okay, so I'm appending 99. I'm in this tuple. Okay, in this list of the tuple, in this list, in the top list of the tuple, I'm adding 99. So because these are two distinct objects, so it won't affect tuple T2. Okay, so let me clear all right. So let me here, I add. Now I show you. Okay, name T1 is not defined. Okay, that's great. I should have. Okay, so this is here, and you can see T1. It is added. So what do you think about T2? Do you think that this 99 will be added to the list of T2 or not?
No,
No. Excellent. Why?
I think it's an independent tuple.
Okay, excellent. So this is independent. So it won't be added. Okay, you could see that because these lists were independent. These lists were independent in memory. So whatever operation you do in the one list of a tuple, it won't affect other tuples. So yeah, this is because they are independent. So that's something very important. And yeah. So this was a very simple example. This is a very simple example when the when the IDs of the data container are different and the IDs of the elements are the same. IDs of the respective elements are different, but the values are the same. So the modification in one tuple or one element won't affect the other. So that's yeah, something very important. So what I'm trying to say, if I modify this, it won't affect this list. It won't affect this list. Or if I modify this list, it won't affect this list because they exist independently in the memory location, as one of your colleague mentioned. Very important. And how do we know? We know by these IDs, the ID of this list, top list, and IDs of the list in second tuple, they are different. So the modification in one won't affect the modification in the other. And another question was like, can we modify? Can we modify a list inside the tuple? Yes, we can modify. So what does the mutability of the tuple means? The mutability of the tuple means that it's the ID of its element will never change. ID of its element, once the ID of this will not change, ID of this will not change, ID of, even when we have added 99, what was the element we added? I think minus 99. IDs of this will not change. Okay, so IDs of this will not change. So let me show you. Okay, so what is an ID? ID of it is here, and after the mutation, yeah, ID does not change. So the mutability of tuple, what does the mutability of tuple means? It means that ID ID will never change. ID of its element will never change. And if we have a mutable data structure, it is possible to change the value of that mutable data structure if it is inside the immutable data structure. So, but IDs will never change. Yeah, we added some element, but its ID will remain the same. ID will remain the same as the previous ID before the modification. ID of this will remain the same. That is what we mean by the immutability of tuple. Immutability of tuple means its ID, its memory location of the elements will never change. So once we have a memory location, once we have allocated a memory for these elements, it would never change. Yeah, that's important. Okay, I mean, if even if it is these things are difficult, these things sounds very difficult. It's okay. Don't worry about them. But maybe in the long run, you should come back to this lecture. You are going to have recordings, maybe read blogs, and as we have still 15 minutes, so I have to cover like a difference between deep copy and shallow copy, and this is very important. And whether you are learning NumPy or PyTorch. So this concept is important. Whether it's a shallow copy, it's a deep copy. You will hear from the Python community all the time. Okay. Oh, it's a shallow copy. Oh, it's a deep copy. So yeah. So it's important to have good understanding of these concepts. So let me go to list. Okay. Okay. So can anyone tell me? So this is the list, two elements. What do you think? This list and this list share the same identity, or they are the different, or they are independent in memory location?
They have different memory.
T1 and T2 are tuples. A
So
is the list.
yeah, A is a list. So what do you think?
Yes.
A in both these tuples share the same memory address or they are different?
Yes, same memory address.
They have the
Yeah,
same memories.
A
yeah,
has the
same.
same memory address, but T1 and T2 have different memories.
Yeah. So T1 and T2, obviously, they are data containers. They are going to have different memory address, but A is going to have a same memory address. So this is how we have created. So if I modify uh, here A here, this modification will show here. Okay. So that's important. So let me again delete it. So the list, this is basically this list. This is basically this list. Okay. And both A they share the same memory address. A in the two tuples share the same memory address. That's very important. So if they are sharing the same memory address, it means that if I modify a list in one tuple, it should be reflected in the other tuple because they are sharing the same memory address. So let me like go deep here. Okay. So I created this 0, 1, 2. So here, yeah, you can see that the memory location, whether I am using this accessing list through this reference or accessing this list through this reference, it gives you same memory location. So here, these two, it gives you the same memory location. And now uh, I'm adding here 555. Yeah. So once I add it, so T2 shows here and T1 shows here. Okay. So this 555 appears in both lists, though I used only one reference to mutate list. Why? Because the list that exist in two tuples T1 and T2 share the same memory location, So that is very, very important. So share the same memory location. That's why, uh, yeah, modification through T1, modification in this list through T1 appears in the list in the here A. Okay, so yeah, this is important. So yeah. Okay, so here, yeah, so let me cover copy. So copy is basically, okay, where is copy? So copy, okay, yeah, here. Let me give you a definition of copies and I will stop here. I think it is too much for today. I would like to give you some time to absorb it, and maybe I will start this lecture tomorrow, and we will also cover iteration. So copy, whenever you hear word copy, so copy means two things. Copy means when you say that A is a copy of B, A is a copy of B. It means that A is a copy of B. So it means that A double equals to B is true. This is true. And A is B is false. A is B is false. So copy is basically uh, a copy of a data structure is something that has an equal value but exists at a different memory location. So that this is what copy is. So if this is true and this is false, you could say that, oh, A is a copy of B. Okay, because they have the same values. They pass the equality test, but the copy cannot pass the uh, um, test for identity because they exist in the same memory loop. They exist at a different memory location. They don't exist at the same memory location. So yeah, and tomorrow we will discuss about shallow copies and deep copies. And even if you are finding it hard to follow what I studied, so what's the way to understand these? First of all, there is a blog. There is a very good blog by Real Python. I strongly urge you guys to read that blog. That's very, very important. And then start from here. This is a building block. So understanding a difference between equality and is operator. That's something from where you should start. And you can also remember that the immutable data type, once you have created them, there is no way you can mutate them at the same memory location. All you will end up having, you will modify, you are able to modify, you are able to create a new object in the memory with a modified value. So you cannot modify the immutable data type like tuple, int, string, boolean, and float. Okay. And yeah. So yeah. So any questions? I mean, if there are any questions, I will stop sharing here.